Hello. In this video, I'm going to talk about simple interest. So, whenever we talk about simple interest, um, essentially you have that it's defined by the following equation. You have that I equals to P times R times T. Now, basically, P is what we call a principal amount. And then we have that R is equal to the rate of interest. Now, one thing that you would have to note is that it has to be in decimal form. Now with t, you have that this is basically just time, but that's going to be in years. Now, one thing to note about simple interest is that simple interest, it accumulates at a very slow rate as compared to compound interest. So one example that we can look at is, let's try to use our formula for simple interest. So let's say that we have that P is equal to 5,000, and let's say that R is equal to 0.095. Now T is going to be 10 months. Okay, so we want to know exactly how can we solve this? Well, the way that we can solve this is by using our formula for I. Now keep in mind that I is the interest amount. It's not including the principal at all. So we take 5,000, we multiply by 0.095. Now keep in mind that that's actually 9.5%. And that's going to be multiplied by 10, but it's going to be out of 12 because there's 12 months in a year. Now, when you multiply this through, you actually will get the following. You'll get that this is equal to 395 and 83 cents. Now, of course, you can use your calculator if you want to. You would take the 5,000, multiply by 0.095, and then multiply that by the 10 out of 12. And we see that we get the same thing, but we're rounding to the nearest cent, so 83 cents. Okay, now one thing that we can apply for simple interest is to look at what we call a mature value or a accumulated amount. So let's say that we take the principal amount that was borrowed and the we add the interest. Now, in reality, this is equal to what I will call A. A is basically an accumulated amount. So what do I know here? Well, I know that P plus I is the same thing as PRT. But notice that the P, it's a greatest common factor, which means that we can factor it out. So this is going to be equal to P multiplied by 1 plus R times T. Okay, so this gives us a formula for what we have known as a mature value for simple interest. Now, if we wanted to, we could say that, for example, that we can solve for the principal amount. But to do that, you would actually need to basically just rewrite it in the following manner. You would have that P is equal to A divided by 1 plus RT. But if you want, you can actually rewrite it as A times 1 plus RT, but raised to the negative 1. So this is kind of like a second formula in a way, but it's only used for whenever you're trying to find the present value or the principal. Okay, and yeah, we'll just say value. Okay, now let's go ahead and look at, for example, one where we use our formulas. So let's say that we have that the principal amount is equal to 3,000. And let's say that we have that this is at a interest rate of 5.8%. And this is going to be paid back in 100 days. Okay, so this means that we want to find the amount that's to be paid back. So the things of which that we do know is that definitely we're trying to solve for a. So a is equal to p times 1 plus r times t. Now the other thing that you would need to know is that most of the time a calendar year is either 360 or 365. So I'm going to go with the 360. So usually whenever whenever you're dealing with a problem like this, it'll actually specify the date, the calendar period. If not, then you know it depends really, like because this is more exact. So yeah, it's gonna be always given, really. Usually, if it's like something else, like a treasury bond, then it might be 365, or if it's like some kind of audit. Okay, so we'll go ahead and plug in. So we have 3,000 multiplied by 1 plus, well, your interest rate is 0.058, and that's going to be multiplied by 100, but this is going to be divided by 360. And we'll just close that. Now, we can actually just use the calculator. So for instance, we know that it's 3,000. And keep in mind that, definitely you do want to show your work as much as possible. And just as long as you're indicating like what you did, then, you should be fine. Okay, so I have that there's $3,048.33 that's to be paid back within 100 days. So it's almost like 3 months, really. Um, so we have that that's going to be 3,048 $48 and 33 cents. Now, interestingly enough, you can solve for the interest to be paid back, but technically you already know what that would be. That would be PRT. Now, let's look at another example that requires just a little bit of algebra. So, for example, let's say that you want to find the interest rate. So, we'll just say, for example, that um, let's say that 5,000 $243.75 is to be paid back in 9 months. Um, in 9 months. So we just want to find the interest rate if 5,000 is to be borrowed. So the difference here is that we know what the future value is. It's the 5,243 and 75 cents. So we'll just go ahead and set this up. Okay, so we know that P is equal to 5,000. We know that R is actually unknown. T is actually 9 out of 12, which if you want, that's equal to, let's see, 3 out of 4. You can do that. Now, A is equal to 5,243 and 75 cents. Okay, so that means that we have 5,000 multiplied by 1 plus R times 3/4 equals to 5,243 and 75 cents. Okay, so let's see. What we can do here is just multiply this through. So we have 5,000 plus, okay, so I have 5,000 times 3/4. Now if you want to use your calculator, you can. So you have 5,000 multiplied by 3/4. Okay, so that's 3750. So we have 3750 R equals to 5,243 and 75 cents. Now to solve for this, we're just going to divide by, or subtract 5,000. But if you do that, that's basically going to give you 3750 R equals to 243.75. Okay, but if that's the case, that means that R is equal to 243.75 divided by 3750. So let's see what that gives us. So 243.75, and this is divided by, actually that's divided by that, isn't it? Okay, and we get 0.065. Okay, so that means that basically the interest rate is going to be 6.5%. Now, keep in mind that basically that $5,000 was borrowed, but that, you know, the interest that was accumulated was the $243.75, and that was within 9 months. Okay. Now, the thing of which that you will look at in the next portion of the material is looking at compound interest. Now, just to give you an idea of like what is compound interest, so let's say, for example, that you had that 1,000 is borrowed at, let's say, just 5%, and that you have, this was after just 1 year. Well, the amount that you have here is going to be $50. So what this means is that you have 1,000 plus 50, which means that the uh, accumulated amount is 1050. Now, of course, if we let another year go by, then in this case, well, not really much is changing. You have that you're going to have 1,000 plus 1,000 multiplied by zero point zero 0.05 multiplied by 2, and this equals to 1,100. Okay, so you can look at it as like, this was the first year, and that this was the second year. The difference, though, in the next topic is that what ends up happening is that if you were to take, for example, the amount that was accumulated after the first year, so like for example, instead you take the 10,000 or the $1,050, and you actually will take the the $1,050 and you will reinvest it or let it be compounded. So this is after the first year. Now, notice that when you do this, this gives you an accumulated amount of 1,102.50. So if you look at this, we can realize that basically there's an extra amount of $2.50 as compared to, yeah, the 1,100 that was accumulated using simple interest. But as you can see, compound interest, this is still after 2 years. So, we can put that this is after 2 years, but with compound interest. So basically, the amount was compounded after the second year, and then we got an extra 250. So what that means is that basically that over time, the interest is actually going to increase at a faster rate as opposed to simple interest. Okay, so that's the thing that I'm going to talk about in the next portion.